But for the Earth to have life, it had to have water. Where that came from is one of the great mysteries of science. There are currently more than 1,000 trillion liters of water on the planet. But many astronomers think that if the early Earth contained water at all, it had very little. At the time the Earth was forming, the inner solar system was too hot for liquid water to exist. The region from the Sun to the asteroid belt was almost bone dry. The nearest water reserves to the Earth were now 250 million kilometers away in the outer asteroid belt. Out here, far from the Sun's heat, water froze and was incorporated into the forming planets and other objects. But how the water traveled from here to the Earth is a mystery scientists are only just beginning to solve. One clue came with the blastoff in January 2005 of an unusual NASA spacecraft. Named Deep Impact, its mission was to fly 430 million kilometers to a comet named Tempel 1 and launch a 360-kilogram copper impactor into its nucleus. The mission was the latest attempt to understand some of the most mysterious objects in our solar system. For centuries, people had argued that comets had brought water to Earth. When they looked at the Moon, it was clear from the craters that its surface had been bombarded by large objects. Similar objects must also have hit the Earth, although our planet's much more dynamic geological activity has since erased all trace of them. Scientists also felt certain that comets contained water in the form of ice. But the Deep Impact mission was the first time anyone had probed inside one. On the morning of the 4th of July 2005, NASA scientists waited anxiously as the impactor approached the comet at a speed of 37,000 kilometers per hour. It scored a direct hit. The explosion was captured by telescopes around the world, and analysis of the debris confirmed that comets contain significant amounts of water. But could they have brought that water to Earth? Using radio telescopes, astronomers have studied the type of water in the vapor trails of comets, trying to find out if it matches the water on Earth. So far, scientists have only analyzed 3 comets, but the results are not encouraging for the comet theory. The water in all these comets was not the same as the water in our oceans. The comet theory isn't dead, but it's losing steam. But in its place, scientists have evolved an exciting new idea. A vital clue arrived on the 18th of January, 2000. That evening, the sky above Western Canada lit up with a bright light. Dozens of witnesses saw a meteorite enter the Earth's atmosphere. Seconds after the event, local photographers took these pictures of the trail it left in the sky. As it fell to Earth, the meteor broke up into dozens of pieces and landed on Tagish Lake in British Columbia. Within days, scientists were on the scene, extracting the frozen remains. The pieces they pulled from the ice were the best preserved meteorites ever recovered. Still intact, a piece was shipped to NASA's laboratories at the Johnson Space Center in Houston. Here it was examined by space scientist Michael Zelensky. The meteorite was remarkably undamaged, despite heating up through friction as it entered the Earth's atmosphere.
The meteorites, they're cold soaked in space for millions of years. So they're very, very cold. And they enter the atmosphere at high velocity, and they do in fact get very hot on the outside. But they're only heated for a few seconds. And that's not long enough for the heat to get all the way in past a few millimeters, actually.
This means that when meteorites hit the ground, they cool very quickly.
You hear of reports of meteorites causing fires on the ground, things like that. That's always wrong. They're actually quite cold to the touch after a few seconds.
But when a meteorite is fragile, like the one at Tagish Lake, where it lands makes all the difference.
Very lucky it fell in a frozen lake. If it had fallen anywhere else, it would have easily fallen apart to dust in a few days. And so it's quite possible this kind of meteorite falls to Earth very, very commonly. It's just usually destroyed.
Because the inside of the meteorite remained frozen, Zelensky was able to analyze what it was made of.
This is a sample of the Tagish Lake meteorite. The black material here is mostly clay minerals, the kind that you'd find in your yard. And these clay minerals contain water molecules trapped inside. And so about 20% of this meteorite by weight is water. That's a huge amount.
From the location and angle at which the meteorite fell, astronomers were able to trace its orbit back into space. They discovered that it came from the outer reaches of the asteroid belt.
If you do telescopic observations of asteroids, what you find is, as you move farther and farther from the sun, the asteroids have more and more water.
Astronomers now suspect that asteroids from this outer part of the belt brought water to Earth. If they're right, our oceans came from space in a torrential shower of meteorites. But one question remains. What could have caused so many asteroids to swing out of their orbit and come crashing to Earth? The culprit appears to be the biggest planet in the solar system. Jupiter lies just beyond the asteroid belt, and its mass is so great that its gravity disrupts the path of any object it comes near. In the distant past, it pulled thousands of asteroids out of their normal circular orbits into elliptical orbits that crossed the path of the Earth. When that happened, collisions were inevitable. The Earth was bombarded. As the asteroids crashed to Earth, they smashed apart, and the water inside them escaped. Explosion by explosion, they created the oceans we see today.
ثم قست قلوبكم من بعد ذلك فهي كالحجارة أو أشد قسوة وإن من الحجارة لما يتفجر منه الأنهار وإن منها لما يشقق فيخرج منه الماء وَإِنَّ مِنْهَا لَمَا يَهْبِطُ مِنْ خَشْيَةِ اللَّهِ وَمَا اللَّهُ بِغَافِلٍ عَمَّا تَعْمَلُونَ